2. Today we are going to do on computer arithmetics. Okay, so now, just for your information, I have listed my email address over the sharing screen. So if you have any problem, actually you can email me through the address, and then we'll try to resolve it through email. In case you have any problem. Okay. So I think now not much problem with that. So I think we should proceed with the uh, tutorial. Okay, so let me see the tutorial. Okay, I don't think, okay, so I think, just I call upon, one by one to share your answer about that. So, number 1A, okay. Let's call upon Arif Izuddin. Okay. If you cannot share on the screen, then maybe you can just explain a bit through the voice. Okay, waiting for Arif to snap the answer. Okay, let's go to the next question. Negative 29, maybe. Okay, let's call maybe Coco Chong. Can you share your answer on 1B? Hi, Coco. Are you going to explain your answer a bit? Okay, Coco mic is not working. Okay. So, okay, basically, I mean, okay, let's see from the screen. We can see that for negative 29, Coco answer was like, Wait. Coco, the answer for B, you have how many answer? Can you type the chat box? Okay, so you wasn't sure about, yes, there should be a two answer. So one is true complement and then another one is called bias representation. Okay, so for negative 29, I think you are using two complements number. Okay, so basically the answer is correct, but the way that you do it is not really that correct lah. Yeah, I mean you are directly using a calculation method for that one. Okay, so okay, thank you for sharing. Let's go back to Arif. Are you ready for your answer?
Yes.
Okay.
Wait. Are you seeing my photos?
Yeah, okay.
Okay, so we use this table start with negative 1 to 8 because this is to the power of 8, to the power of 0, to the power of 1, 2,
Mm-hmm.
3, 4, 5, 6, 7, to the power of 7,
Mm.
which is negative. So we want to find 78. So we will use this 64 plus 8 plus 4 plus 2 will be 78. So we put 0, 1, 1, 0, 1, 1, 0, 1. So this is the answer.
Okay, so your answer is 0, 1.
0, 1, 1, 0, 1, 1, 0.
These are your two complements, right? Arif, is it?
Uh,
This is your two complements number.
uh, this is two complements number.
Okay, okay. And anyone got different answer from Arif? Yeah, I think most of you should get a different answer.
As this is 0.
Yeah,
I'm
0,
sorry.
right?
This is
Yeah,
0.
so
I'm
it's
sorry.
0, 1, 0,
0,
0, 1, 1, 1,
1,
0.
0. Yes.
Okay, yep. Okay.
This is
Why you use this method?
for me it is more simpler.
Simple. But Dr. Chia did not teach this method, right?
Yes.
Did Dr. Chia teach you about this method?
Yes. It's in the video.
Oh, okay. He said just use this table to do the calculation.
Yes.
Okay. Sure. How about the bias weight?
This bias weight, we just use this times 2 to the power of 7 because one we need to get 1 at the front.
Mm-hmm.
So we just uh take this point here and times 2 to the power of 7.
Okay. I don't agree with this lah. This is not the bias representation in here once at first. Yeah. Okay, but never mind. Yeah, we will check the answer. Okay. Thanks.
Okay.
Okay. Yeah, let's see. Let's see my screen. Okay. The thing here is that, okay, first of all, this you have to answer what? You have to answer two. You have to have two answers for each of them. So 78, okay, this is easy. I mean, because 78 is a positive number. So if you know about two complements, the number will start, actually it will start from, if positive, it will start from 0. So eventually, yeah, you can just directly convert it into a binary. Okay, so that's it. Okay, that's it. So what's next is the two complement is the same thing. Because it's a positive number, you don't need to convert it. Then how about the bias representation using 8-bit? Here already tell you that you have to use 8 bits. So when we use 8-bit, the bias representation, yeah, is using this formula. So you must always remember when you use a bias representation, the formula is 2 to the power of n minus 1 minus 1. Okay, which here is 8-bit here. So you minus 1, you get 127. For that, plus 127 is actually equal to 205. Okay, and then you need to convert the 205 into the binary. So this will be the 11001101. Okay, so this is how to calculate the bias representation in 8 bits. Okay, so for the next one here, okay, I'm not sure, wait, sorry. I'm not sure did Dr. Cha actually teach you using the one that presented by Arif on two complements, but for me, I think it would be better for you to understand actually how actually the two complement has been is working. So first thing okay, again, we take the 29 here and convert it into the binary first. Then if it's a negative number, you want to convert it into a two complements, always remember two steps. One step is inverts all the bit. Second step is plus 1. That is the correct way to actually do a two complement representation. Okay, so for the two complements, you need to invert all the bit. So this one become 1, 1, 1, 0, and then 0, 0, 1, 0. Okay, and then plus 1, this one become 1. So this is your answer. Okay, and then the bias representation is the same thing. Okay, same thing. So again, it's 8-bit. So you use the formula 2 to the power of n minus 1 minus 1. This is the bias. Okay, this is called the bias. So the bias will be negative 29 plus 127. Okay, of course, I mean, if you do the calculation, 8-bit is 127. Yeah, and then convert it. Okay, so don't get confused with the thing. I mean, of course, I mean, technically, if you use the calculation just now, Arif presented, is not wrong. I mean, basically, you still get the answer, but I'm not sure whether the step is correct or not. Okay, because this is the correct way to do the, two complements. Okay, so any problem on question 1? Can we use manual addition for bias representation? What do you mean? Manual addition? Yes, you can. I mean, you mean you want to use binary addition is fine. Yeah, it's fine. I mean, if you want to use binary addition, you just convert this one, use this one, and then convert this one into binary, then plus them together. Yeah, you still get the same thing. Okay, I think it's okay. Okay, so next. Okay, here, this is, I just want to show you what is represented by the bias binary. Okay, normally in this case, for example, 127, if I want to represent negative 127, I use 0 to represent, okay? And then if I want to represent 128, I use all 1 to represent. So you can see that if negative 127 plus 127, this is the bias, this is the bias, it will equal to 0. So this is a bias representation. Okay, that's the idea of the bias. So another example is here. You see, this is only for 4-bit. So 4-bit, this is my real, but you say, hey, how do why I cannot draw it? Okay, the one. This one is the real implementation, real thing here. Okay, so you can see that everything is shift. Okay, so the 0 shift here. So if I want to represent negative 7, it will be 0. Okay, and if I want to represent negative 3, it will be 4. If you use back all the things that you have done before, okay, then you know what is actually is working. Okay, so for the next, represent the following 2 complements. Okay, maybe ask another one to share. Stop sharing. Okay, who? Siti Sakina. Yeah, can you share your question? Share your answer for question 2. Okay, just for preparation, in case you haven't snapped your question 3, maybe Kavitavani, is it? Am I correct? Kavi? Yeah, later you will share your question 3. Kavi, are you there? Yeah, okay. Okay, so let's see question 2 first. Okay, yeah, quick one. You can explain both of them.
Hello.
Okay, yep.
All right. Okay, for number 2A, I just use, okay,
Oh, you
because
use this one, the table also.
just use the table to understand.
Okay.
So actually we have like 7 bits. So that's why I use negative 64 at the beginning.
Okay.
All right. And then I just put the number in the table and just add to get the answer.
Okay. Okay. So I think no objection to the answer. If any objection, let me know. I did not check it, properly. Just let me know in the chat box or anything. So you get a negative 21 and 45. Okay. So in case you want to use my method to do it. So how would you do it for A? Hey, hello. Okay, so the idea here, you need to know that, okay, first thing, of course, when we talk about 2 complements, again, first thing first, what you need to know is that always check the first number. If this one is 1 means negative, okay? Then do the conversion, okay? So if you know this is the negative, how I do the conversion in 2 complements? First, again, same thing as converting back. Invert all the bits. So 0, 0, 1, 0. 1, 0, 0, and then plus 1. 0, 0, 1, 0, 1, 0, 1. Okay, then this one is equal to 20. Okay, so equal to 21. So remember to put back this one inside here. So this one is negative. So it's negative 21. Okay. So of course for B is easier, nothing more, much more. You just convert it. No, you just convert it into binary. No need to translation because it's a positive number. Okay. Okay. Kavi, next question 3.
Hi, can you hear me?
Yes. Okay.
Okay, don't get shocked seeing this. I just wanted to prove. Okay,
Okay,
so
sure.
for 8-bit, I got this value. And then for number 12, I got this. Then I just edit.
Okay. So addition, no problem, right?
Yeah, no problem.
Okay, A, no problem. How about B?
Okay. So for the B part, the 12, I invert it, and then I add 1, and then this is the value I got it. And then I just add like normal addition.
Okay, this one have no problem too. Okay, next.
Yeah. For C,
Okay,
I
the conversion is
inverted.
fine. I think it's okay. Just explain the
Yeah.
addition part. Yeah.
Yeah, the addition is just normal addition lah.
Okay, and then
yeah.
yeah.
And then for this part we will have an extra bit. So the carry bit we can just ignore it.
Okay, so why we ignore the extra bit?
Because initially it's just 8-bit. So since it's like the answer is 9-bit, so the extra bit we can just ignore it.
Okay, a more precise answer is like, because like for example, a processor is 8-bit or the memory is 8-bit, so it only can contain up to 8-bit calculation. So anything more than that, it will be ignored. Okay.
Okay.
Yeah, and then number D.
Okay. Then for D, so the answer there will be an overflow because the two positive numbers produces a negative value. So since it's a negative value, we can just classify it as an overflow.
Overflow also means that it's a wrong answer. Okay.
Yeah.
So
Yeah.
why an overflow will happen?
Why it happened?
Yeah.
I'm not sure. Leh.
Okay. Thank you. Okay. So
Okay.
anyone know why overflow is happening in the question 3D? Can type in the chat box. No one? No idea? Okay, yeah, I see the idea. Exceed the number of bits, yeah, as it is more than 127. Okay, because this is a 2 complement. Okay, 2 complement only able to process negative 127 to 128. So that's the maximum. So when 132 is it's out of the range of 2 complement in 8 bits. Yeah, so that's why an overflow occur. Okay, yeah, Iris correct. Yeah. For 3C, you got 7. 3C, you should get negative 17. Yeah. Even you ignore the carry bit, then the answer is still 17. Negative 17. Okay, so for question number 4. Okay, question number 4, let's call upon someone, maybe Ziqing, are you there? Okay, yeah. Have you done question? Don't know how to do number 4. Okay. How about Sui? Do you know how to do number 4? Sui? Okay, yeah. Maybe Sui can share the answer first. Okay, your unmute is on top.
Hello? Can you hear me?
Yes, yeah, can.
And can you see my screen?
Mm.
Sorry, it's a bit blur. But
Okay, maybe make it larger a bit. Okay, yeah, okay.
so this question is negative 15 times negative 7. So I find the value for the negative 15 and negative 7. And then since negative 15 is right, so I and then negative 7 I put it as the Q. So I set the initial value for A is 0, all 0, and then Q negative 1 is also 0. So I shift the last number from the Q to Q negative 1. So it's 1 into 0, so we need to minus the A. A need to minus M. And then after I manage to minus them, then I shift. So this is the continuous cycle for these calculations, and we need to do 8 cycle because since this calculations is require 8 bits, so we need to do it for 8 cycles. So the final answer that I get is I convert this 16 what is called bits into binary. So 105 is my answer.
Okay, so your final answer is 105 base 10.
Yeah, base 10.
Okay. You hold on first. Don't off the screen first. Any problems on this question 5? Question 4. Okay. Kugaraj say he used 5 bit. Okay. Okay, we will discuss about that later. So any problem with this or not? If not, I will assume everybody know how to do it. Okay, someone don't understand. Just one? Okay,
So I
okay.
stop sharing now.
Yeah, stop sharing. Okay. Thanks for Sui for sharing. Okay, yeah, okay. Seems like many also still confusing about this thing. Okay, never mind. Let me share mine. Okay. Okay, wait. Okay. I think you all can see my screen. Okay, first thing of all, you need to, okay, you need to know, okay, I'm not sure you know about this diagram or not, lah, but the thing is that this diagram is actually represent the Booth's algorithm. Okay, so where in this Booth's algorithm, that's the step, okay, according to the diagram over there. So if you see the diagram, then you will know what is actually happening in the diagram. So based on this, okay, first of all, just convert it. Okay, so -15, -3. So -15 and -3, you should know that which one is a multiplicand, which one is a multiplier. Okay, so you convert them. Actually, for -15, you can represent using this, and then this is the respective part of 15, and then this one, -7 and 7. Okay, so the step here will be like this. Okay, yeah, just try to follow me. I'm not sure whether you all can follow, because it's a bit hard to do it on online kind of thing like that. Okay, so first thing first, okay, you check on this diagram, what is the first thing you need to do? When you start, the first thing you need to do is actually you do a you do a calculation on this one. So first thing first, what you need to do is you need to put 0 into A. So you see here, because we are using 5 bits only, so you can put 0, 1, 2, 3, 4, 5. Okay, 5 bit. And then Q -1 equal to 0. This one, 0. And then put your multiplicand into M. Okay, so your M is here. So which one is your multiplicand? Is the -15. So it's 1,0,0,01. Okay? And then your multiplier is -7. So it's 1,1,0,0,1. Okay? So this idea. So this is the first round initial step that you are going to do. Then after you've done the initial step, what you do next, you check your Q0 and Q -1. So you know Q -1, Q0. Q0 is this one. The last one of Q is Q0. So you check this one and check this one. So it's 1 and 0. So when you check it's 1 and 0, you check back here. If 1 and 0, what do? You go here. A minus M. Okay? So you do A minus M here. So A minus M, which is actually equal to A minus A plus minus 15. Okay? No, sorry. Not this one. So it's A minus 15. Okay? So eventually it becomes A plus 15. Okay? So you know that A plus 15 is here already. So easily you do 0, 0, 0, 0, 0. And then you do a plus 15. 15 is 0, 1, 1, 1, 1. So your answer is 0, 1, 1. Okay? So 0, 1, 1, 1, 1. So after you done the shift A, Q, and Q minus 1, everything shift to the right. So means that this one throw away. So this one shift here. So this one become 1. Then this one is 0. This one becomes 0. This one becomes 0, 1, 1. And then this one go here. So this one become 1. Okay? And then this one come here, 1, 1, 1, 0. And then what we add here. Okay? If it's a 0, then just add 0. If it's not a 0, then no need to add. I mean, if it's a 1, then you add 1. Okay? So this is a new one. So this is the first cycle. Okay? And then you check again. 0 and 1, what you do? If 0 and 1, you do a plus M. So A plus M. okay, which is equal to A plus minus M. Okay, so 0, 0, 1, 1, 1 plus, okay, minus 1, 0. Okay, wait a moment. Okay, so it will be plus 1, 0, 0, 0, 1. Okay, so you just plus them together. So when you plus them together, it will become 0, 0, 0, 1, 1. Okay, again, do the shifting. So it's 1, 1, 1, 0, 0. And then this 0 come here. And then this become 1, 1, 1, 0. This 0 come here. So this becomes 0. Okay. Okay, so until the next step. Okay, the next step, again, we check for this 0 and 0. So when we talk about 0 and 0 here, what we do, we don't need to do anything because 0, 0 is here. So you just shift. So you just shift whatever is it. So it's become 1, 1, 1, 0. Okay, I don't know what happened here, but okay, let's continue. 0, 0, 1, 1, 1, 0. Okay, so you just do the calculation like that. Okay, so always check for this one. So when we until here do this one, 1 and 0. So when 1 and 0 here, you need to do the A minus M again, something similar like this. And then after you do that, you will have a final shift. And then this one is actually depending on your number of bit. This is 5 bit. Okay, remember we have the count minus 1 here. So C equal to 5, 4, 3, 2. After shifting 1, it will become 0. So after the final shifting, it will become 0 and then N. Okay, so okay, why do we need to add 1 instead of 0 when shifting? No, that depends. You check here. When you after you shift, like for example, if you shift this one, if this one is 1, then this one should be 1. If this one is 0, then this one should be 0. Understand or not? What's the reason to do this? Actually, is to maintain the positive or negative power, the sign. Okay, we need to maintain the sign. Okay, so eventually, your final one will be 0, 0, 0, 1, 1 for your A, and then 0, 1, 0, 0, 1 for your Q. So, and then combine these two together, you should get a 105 base 10. Yes, correct. Sui, you use an 8-bit, but that's not wrong. 8 bits is still fine. Yeah, I mean, you still can use 8-bit, just a bit wasting of time because the necessary one is only need 5-bit to do the calculation. Yeah. But if you use 8-bit, you just need to do 8 cycle. That's it. Okay? Okay, I hope it's clear. How to determine. Yeah, you need to check after the conversion, you need to check here, this one. What is the possible one? Because like 15, you need to at least have 1 0, like to know that, okay, this is 15. Okay, Asri, what is the other way you are using? Asri, what you mean other way? What other way? No, cannot, because look at the question again. The question say need to use the Booth's algorithm. If it didn't specify, then you can use. But when it's specified, then you have to use the Booth algorithm. Okay? Okay, so yeah, I think okay, should be okay. Just remember, you use this, just follow the diagram. But of course, in the exam, you won't have the diagram. So you need to remember the step to do it. Okay? So that's it. Okay, let's go to the last one. Okay, last one, I think is quite complicated anyway. Okay, so now you need to do the division. Of course, first thing first, whatever. Okay, this is the flow chart for the division. Yeah, whatever is it. I think you have in your slide or anything like that. So again, the same thing, you need to do a initialization. So how to do the initialization? Again, the same thing. You can just do the initialization. Okay, where set A equal to 0 and then set Q equal to dividend. You should know what is dividend. This one is dividend, then this one is the divisor, and then your count. Okay, this one here we use 8, so the count is equal to 8. Okay, in here, first thing you do is shift to the left side. So it's another way around. Just now we are doing, for multiplication, we are doing this way. Now we are doing this way. Okay? So when we are doing this way, when you shift, what you need to shift A and Q. So, okay, I think you should know how to do the shifting in Q. So it should be something like this. Okay? You see, this one is shift here already. This one shift here already, or shift another side already. So that will be your shifting. And then after your shifting, what you do? Okay, after your shifting, the first thing you need to do is A minus M. So what's your A? Your A is 0, 0, 0, 0, 0, 0, 0, 1. And then minus M. Okay, you minus M. M is actually this one, 1, 1, 1, 1, 1, 0, 1, 1. So this one is your 11. Then 11 equal to 1, 0, 1, 1. Then negative 11 equal to, okay, I should add another one here. So this should be 0, 1, 0. So it's like 1, 0, 1, 0, 1. Okay. So you should plus a negative 11. So if it become 1, 0, 1, 0, 1. Okay. So this one 0, 0, 0, 1, 0, 1, 1, 0. Okay. So this will be your addition. After your addition, it should be something like that. Okay. So after your addition, okay, I do something wrong. Yeah, sorry. I forgot about that. This is wrong. Okay. Sorry, this one, yeah, that's why use 8-bit is sometimes good also. Yeah, this should be the correct one. So it's 1, 1, 1, 1, 0, 1, 1, 0. Yeah, this one. Okay. So use 8-bit lah. I mean, put this one at 8-bit to be actually confirm with your answer. So when we see this, okay, you can check here. 1111, 0111, this is your answer. But after that, you will see whatever after this, okay, you will check because this is A now, the new A now. You store in A is this answer. So you check whether A is less than 0 or not. Okay, so you check this one is less than 0 or not. You check the first bit because it's 2 complement. So 1 means less than 0. Less than 0 means yes. Yes, then you set your Q0 equal to 0. Set this one equal to 0. Okay, it's already 0, so set it again to 0. And then do a plus M again. So you need to plus M. Plus M means plus this one. So 0, 0, 0, 0, 1, 0, 1, 1. Plus again, the answer actually equal to 0, 0, 0, 0, 0, 0, 0, 1. You can see that after I do this, it's actually equal to this one. This one equal to this one. So we here it called restore, which means that actually you don't need to do the calculation. Okay? You don't need to do calculation. You just need to restore because you already know that after it when it go to this one, A minus M, it will go back, it will restore back to the original answer. Okay? So, okay, let me check. Must the number of bit for A and Q to be the same? To be safe, I think is to be the same is the better lah. Yeah, you see, I make even mistake with the M also. So is this necessary? Yeah, same bit. Okay. I mean, just to be safe. Okay. I mean, if you can calculate, then it's fine also. Okay. So next. Okay. So again, for the next step, shift again because we have done and minus 1 already. We go back and then shift again. So after shifting now, A become 1, 0. And then you do a minus M again. Okay. After you do an A minus M, and then again, when you do A minus M, this one is negative. So negative means that you restore. So you restore back to the original answer again. Okay. So next. Yeah, after here, okay, this one is just a step, some step to do because it's all minus 1. I just want to show you is the A does not need to do the A plus whatever thing is it. So here, after you shift for this step, okay, this one is A minus M. Okay, so after you do the A minus M here, you see here, it's not a negative number, it's a positive number. Means that A less than 0, no. So go here. You just need to set the Q0 equal to 1. So set this one become 1. Okay? So just remember the step. When it's yes, do this, do the restore and set the Q0 equal to 0. When no need to restore, but just let the Q become 1. Okay? And then, yeah, that's it. I think this is a 2 different calculation method that you're gonna use in here. So again, because I'm using 8-bit, so you need to do 8 cycle. After you do all the 8 cycle, you should get something like this. So the final answer is here. This one, Q will be your quotient, and then this one, your A will be your remainder. Okay? Yeah, this is how you're doing the calculation. Okay? I mean, maybe some of you can't get now, but yeah, after, I mean, you got this sample, and then yeah, after go back, you try to do the calculation by yourself. Okay? Okay, let's see, because yeah, I will leave it a while for that, and then let's see if they are done with the course already. Okay, any question beside that? Do exam will ask this kind of question? Well, it's hard to say. Yeah, you can refer to the past year and check whether they come up with this kind of question or not. Yeah. Okay, any other question? Okay. The number of cycle depends on the number of bits of Q. Yeah. I mean, based on A and Q lah. I mean, usually I will use both of them as the same bit. Yeah. So it depends on both of them. Okay, so yeah, so again, I post my eh, Hui Ying, you mean do you mean by you reverse the multiplier and multiplicand? Okay, I mean for for multiplication, technically lah, I mean it won't be wrong lah. Yeah, I mean technically multiply. I mean which one multiply, which one is still the same. Yeah. Okay, so again, I post my email. So in case any one of you have any questions, you can just email me. Yeah. Okay, if no question, we just wait to go back to our main session. Yeah.